Next one is star schema. When it comes to data warehouse or business intelligence, what is business intelligence? How many of you remember this term? So as part of any business intelligence project, you take any tool, reporting tool or ETL tool, everything falls under the term called business intelligence. Business intelligence. As part of business intelligence, there are two streams. One is the ETL. You remember in Power Query Editor, we did all the data cleaning, data formatting, everything, okay? And one stream is ETL. The second one is reporting. So in the case of reporting, especially in business intelligence, we, instead of saying data model design, we say dimensional data model design. There are two types of data model design. One is the star schema, okay, star. And the other one is snowflake schema. This is your star schema. What do you mean by star schema? In star schema, what you are seeing, right? This is your star. In star schema, we have a central table called sales fact. You know, this is a central table surrounded by dimension. These are the dimension tables, surrounded by dimension tables. Okay. So in this case, since the fact table is surrounded by multiple dimension table, it appears as a star. It looks like a star, hence it is called as a star schema. Okay. In these fact table, right, the sales fact table, apart from this, you have some other columns like, let's assume that you have something like revenue column is there. Apart from these columns, okay. In addition to that, you have revenue and quantity sold and profit. These are the number columns, okay. In the fact table, you will have the key, all the dimension tables keys plus the fact. The number columns are called fact. It is also called as a measures, okay. It is also called as facts or called as measures. The interview, they ask you, what is a fact table? Fact table is nothing but the keys from all the surrounding dimension tables plus the measures or the fact. Measures or fact, okay. What is a fact table? It's a combination of the keys. What are the keys? Customer key is there, right? Here also customer key is there. Product key is there. Product key is there. And you have reseller key. Look here, reseller key. And then sales order line key. It is there here. And likewise, the sales territory key will also be there here. If you scroll down, yeah, it is there here, sales territory key. The keys from all the surrounding dimension tables, you will have it in your fact table, plus the measures or facts. It is nothing but number values. Yes, Pavitra, you are correct. Okay, this is what a fact table is all about. And okay, what is this table? These are, let's assume that these are dim customer, dim product, customer dimension table, product dimension table, date dimension table, sales territory dimension table, sales order dimension table, reseller dimension. Sorry, these are, yeah, maybe, we can say reseller dimension table. Okay. And if you notice one thing here, okay, now the question is, what is a dimension table? I said these are dim, right? Dim table or dim date. What is a dimension table? Dimension table, each dimension will have the primary key column in it. Primary key, or it is also called a surrogate key. Use this fancy term, surrogate key. That means in this table, in customer key column, you are not supposed to have duplicate records. Even if you try to insert the duplicate record, it will reject it. That is what primary key or surrogate key is all about. So, okay, what else is there in the dimension table? Okay, the dimension tables will have the combination of the surrogate key and the descriptive information about your facts. This is what your dimension table. In the interview, they ask you what is a dimension table. Dimension tables are nothing but the combination of the surrogate key or the primary key with the descriptive information of the facts or measures. Okay, so this is my sales fact table. Let's say in this sales fact table, I have columns like the invoice number and invoice date. And then you have something called customer ID or customer key, comma, product key, quantity, and etc. Okay. These columns are available in this table. And in here, if I say something like quantity is 52, if I say the quantity is 52, invoice number is 101, invoice date is something, okay, and customer key is 101 and the product key is 101. It need not to be 101. Just for example sake, I'm putting these values. Okay, if let's say you are a manager, when you are asking me, can you tell me how many units we sold? And in this particular invoice number 101, so you can tell him 52. And 52, if you tell what he can understand. Does this give any descriptive information? No. 52 is a number, it's a quantity, fine. 52 quantities we sold in this invoice number, but I need more context. This table will have customer name in addition to the thing, right? In addition to the key column, it will have the product name. Customer name, product name. So if you tell the 52 units were ordered by a specific person, Ashok, and again, which products he ordered it, right? So product is something like a Dettol soap and Dettol hand wash. So instead of saying just 52 to your stakeholder, if you tell them 52 is nothing but the number of units ordered by a person by the name of Ashok, and he bought Dettol soap and Dettol hand wash. Okay, all these things put together, this is what we are getting at. So the dimension table helps you to add a context to your fact. The Ashok, the customer Ashok bought 52 and he bought the Dettol soap and hand wash. If you give this information, if you give this additional information, it gives more context, right? So that is the reason why I use this term, descriptive information about your facts. What is the fact? The numerically 52, in this case, quantity. With the help of the product key and customer key, when you join these two tables, right, you can get the customer name and product name. If you simply say 52 in product key 101, what will he understand? You are selling 1 million products. What the hell 101 is all about? If you tell him the product name, then you will be happy. So the product name is available where? In the dimension table, along with the key column dimension. So what is a star schema? Star schema is nothing but the fact tables are surrounded by the dimension table. What is a dimension table? Dimension tables are nothing but the primary key or the surrogate key plus the descriptive information about our facts. What is a fact table? Fact table is nothing but the keys from all the dimension tables, all the surrounding dimension tables, as well as the measures. It will have the keys and measures in it. And also, if you look at it here, if you take a close look at it here, the key column, customer key, product key, right? All the dimension tables, key columns flowing from top to this bottom fact table or the transaction table. Look here, this product key goes down. Can you see it here, right? The arrow. It goes down. If you see here, it goes down. It goes towards your sales fact table. All the dimension tables, if you see, the data are the keys are flowing from your dimension table to your fact table. And if you see here, it's a 1, 1. The dimension tables are on one side. And then the next to the sales fact table, you can see star here, many. But in this case, it is 1 here only, 1-to-1 relationship. You can ignore this one. So one-to-many. In general, the dimension table and fact table will have one-to-many relationship. Okay, now you understood what is star schema. Okay. Next one is the snowflake schema. We have something called snowflake schema. It is an extension of my star schema. But unlike the star schema, in snowflake schema, we normalize the dimension tables into multiple levels. We normalize the dimension tables into multiple levels. So even here also the fact table is there. The fact table is surrounded by dimension table. Everything is good. But if you see here, this dimension table, a single dimension got broken into 3 different dimension tables. 3-dimension tables. We have splitted a single dimension table into 3-dimension table in this case. The dealer dimension table may be right. It got splitted into 3 different tables like location dimension table, category dimension table, dealer dimension table. Okay, in this case, if you notice it, the location and country dimension tables were not directly linked with my fact table. Only the dealer dimension table linked directly with my revenue table. So then what is the advantage of this one? Before that, okay, so adds additional dimensions. In the case of snowflake schema, it adds additional dimensions, usually representing hierarchies. It is something like country. Each country you have location 1, location n, and each location you have different dealers, dealer 1, dealer 2, etc. Okay, usually the snowflake schemas or dimensions will represent the hierarchies. This is called your hierarchy. Okay. The advantage of snowflake schema is it consumes lesser disk space. But the disadvantage is you need to join multiple dimension tables in this case, in the case of snowflake schema. Okay, joining multiple tables will literally slow down your performance. For example, if I wanted to access the information from location dimension, or if I want the location dimension table to filter the revenue table, it has to talk to this guy and it has to, you need to join these 2 tables to access this information. Okay, or if you want to see in which dealer, in which country, how much revenue we made. So in that case, you need to join this one with this one because these 2 are not directly connected to the fact table. Hence, everything is kind of an interface for them. The dealer dimension table and branch dimension tables are kind of an interface for those things because it cannot directly talk to him. Okay, the location and dimension table cannot directly talk to him. Supposing you wanted to filter the location dimension tables, if you want to use your location dimension table to filter this table, yes, you need to filter this table via the dealer table only. All you need is you want the location table directly filter this table, but that is not possible because the relationship was not directly created. The relationship exists between dealer and location and dealer and fact table. There is a direct relationship exists here. It is an indirect relationship. In this case, if I wanted to know location-wise total revenue, even to answer this simple question, the revenue table have to have access to it, and this one has to have the access to this one, which means it has to join, fact table has to join dimension table, and then it has to join this table. It is a overkill. It requires a join, right? So in that case, multiple tables query performance is reduced. Okay, multiple. If you break down, especially when you join multiple tables, it will literally slow down your performance. Not only this is applicable for Power BI, it is common everywhere. Just give me this. So Snowflake is an extension of my star schema. Even in the case of Snowflake schema, the fact tables are surrounded by a dimension table, but not all the dimension tables are directly linked with your fact table. If you want to use any dimension table to filter your fact table, it should have direct relationship. But if that has any indirect relationship, you need to navigate to the table which have the direct link with this table. So location table have a direct link with it. You need to have this table. You need to join these two tables and you need to join these two tables. Only then you'll be able to filter the fact table. So in this case, I'm talking about location dimension, okay? Since joining multiple table will literally slow down your report. That's the reason why Microsoft suggests better you can use the star schema instead of using Snowflake schema. Okay, how do I, see this is what the tables that I have it in my hand. How do I, is it possible to convert the star schema? Yes, that is possible to convert this as star schema. You need to combine these through tables in a single table. This is called denormalization. Denormalize the dimension tables, denormalizing. DE, okay, DENO, denormalize the dimension tables. So that all, which means combine all the three into single dimension table so that, the each dimension table will be directly linked to your fact table. Got it? Now, what is the difference between star and snowflake schema? Star, in both the star and snowflake schema, the fact table is surrounded by dimension table. Whereas in the case of snowflake schema, the dimension tables, there are some cases, the dimension tables, they would have broken it into or splitted into more than one dimension table. So those tables you have splitted it, that one has a direct relationship with the dimension table. And if you wanted to use any one of the newly created dimension table to filter your fact table, it has to navigate via your dealer dimension table. Hence, it requires multiple table join. Multiple table join is not at all preferred in the case of huge volume of data. It will literally slow down your performance. Hence, Microsoft themselves, they recommend to use the star schema. Next one is, okay, Pavitra, I understood you are exhausted. Okay, and I'm going